Hi everybody, it's Mrs. Dinkelman, and we're in the section in Unit 12 called the Calculus of the Parametric Equations. So now all the questions that they're going to ask us on the calculus exam about parametric equations, now that we've gotten a little bit of the basics under our belt. So this first one is about the first derivative, so dy dx. We're just going to take the ratio of how the y is changing and how the x is changing over the top of each other. So hopefully that sort of makes sense, just the dy over the dx. The other thing we could do to kind of make sense of that is to say, oh, this is the same as dy dt, and if I flip and multiply that, I get dt over dx, and then technically those dt's cancel. The weird thing about talking about it that way is technically dy and dt and dx and dt are like 0 over 0. So there's some strange things happening there, but that's just another way to remind yourself that yes, this is going to work just to find the derivative of how y is the derivative of y with respect to t over the derivative of x with respect to t. And then this one says here that dx dt can't be 0. Basically, if dx dt is 0, one of two things happens. So remember what happens if we have a number over 0, that's really an undefined, and that usually means we're going to have a vertical tangent. If we end up with 0 over 0, remember this is called indeterminate because everything, almost everything times 0 is 0. So the reason that this is different is we can't pin down one answer. There's an infinite amount of answers here. So we basically don't know for sure what's happening at that location. We might have to look at a picture or do some more analysis there. Okay, so the first one, find the equation of the line tangent to the parametric curve. So let's just find out what dy dx is going to be first. So dy dx, and sometimes for myself, I write that I'm going to do dy dt over dx dt, and I think that's helpful, especially on a free response, so that you can make sure you have all the pieces. So there's dy dt, and then dx dt. It's a minus 12. I was kind of looking away as I was doing that. Okay, let's figure out what's happening at 0, 4. Well, here's the problem. 0, 4 is the xy, and so we want to make sure that we figure out what the t value is. So I'm going to go ahead and just set this equal to 0 first, and I'll factor out t cubed and be left with t squared minus 4. So there's a couple ways to get 0 here, 0, 2, and negative 2. So out of those, we want to figure out which one's going to get us that one. And I guess there's more than one. That's funny that I picked this one. Make sure I have everything right. So maybe we need to find two equations. Well, certainly it's not going to be at 0 because 0 isn't going to work for this particular situation with the y. But let's figure out what's happening at t equals 2 first. So t equals 2. So we're going to get 4. I might have picked a really, really big numbers here too. So let's see, 2 to the 4th is 16. 16 times 5 is 80. 2 squared is 4, and then that's going to be 48. So we're going to have 4 over, let's see, 32, so 1/8. So one of our equations is going to be y equals 1/8 x minus the x coordinate. Don't really need that part, but it's just habit for me. So there's one of them. Let's see what happens when we have a negative 2, and I think I'm going to use just most of what I have here. I think the only thing that's going to change is that the numerator is going to be negative. So I think we're also going to have one that's negative 1/8 x minus 0 plus 4. So 4. Okay. So what you might do at this point is you might just go do those problems on the assignment that talk about the first derivative, just get a good hold on that, and then we'll talk about the second derivative. So if you want to pause and go do that and then come back, that's fine. The second derivative is not exactly like you think it might be. So this is going to be a lot of notation. We're not just going to take the second derivative of the y over the second derivative of the x. That's what that note says there. There is a little bit of extra things that we have to do. So sometimes saying this in words rather than thinking in symbols can be helpful. So really step 1 is you're going to take the derivative of dy dx. Now technically that dy dx, that's going to have t's in it. So it's really the derivative with respect to t. And that's not technically what this is asking. So that's why there's a second step here, because technically what d squared y over dx squared means is take the derivative of y twice and make sure that you've taken it with respect to x both times. And so we have to make this adjustment here because technically we did this one with respect to t. So that's where this divide by dx dt is going to come into play. Okay, so let's just take a peek. This is just asking us to take the second derivative of whatever we had up here. So I'm just going to hopefully rewrite that. I picked a big, kind of a big example here. So we already got that dy dx was 2t over 5t to the fourth minus 12t squared. And it actually might be helpful at this point to actually, I'm going to do it. I'm going to do two things. Well, I was going to write it this way, which I will. Okay, and I think I would have to do quotient rule in that form, so I think I can be sneaky and get away without doing it by calling it this. Okay, so I'm going to go ahead and take the derivative of that again. And if you want to write this, you can. If you want to just say second derivative equals, whatever you want to do there. Okay, so remember here, we're just going to take the derivative, just pretend like nothing's different. So let's see, -2, leave the inside alone. This becomes a -2, and then we have to multiply by the derivative of the inside. Okay. Now, normally we would be done, but technically what this is, just by the way, this is not really a true statement yet. Technically what I have is the second derivative of y, first with respect to x, because that's what was over here, but the second time what I've technically done is I've taken it with respect to t, which is not what I want. So that's why I have to do this extra step, and I have to divide by dx dt, which is just this thing again, or I guess simplified maybe would be better. Nope, I can't simplify. It has to be dx dt, and that is dx dt. So don't do that one. Now, I don't really want to simplify this right now because, I don't know, it's going to be a mess. I'm just going to leave it that way. I'm going to erase over here. So now, because I've taken that extra step, then I have done what I needed to do for my second derivative. So don't forget, and maybe you know already, what the number one thing people forget on second derivative for parametrics is that divide by dx dt again. So again, what you might do, go find the second derivative problems on your assignment, and then you can come back and we can do arc length. Okay, so we have a smooth curve here again, and we're just looking for the arc length given these two. So this to me isn't vastly different from what we saw before. So just a quick reminder that in normal mode, our arc length, I'm going to write L equals, was again, function mode is just the integral of 1 plus dy dx squared. I don't know why it keeps doing that to me. I'm going to stop inking for a second. Okay, let's try again. I think it's because of where I chose to write, but we'll see if we can still make it work. So we want dy dx squared in here, you know, from A to B, whatever they choose to give us. So if we can think of this instead as, and when we proved this, this sort of happened. We had a dx here, which is 1, and then a dy dx, which is what our formula was. So this is really similar if what we do is just change all of these to dt's. That should have a dt at the end of it now that I'm seeing it. So let's fix that real quick. I don't know why that didn't have a dt at the end. Remember, technically on the AP exam, if you don't have it, you're not going to lose any points, but mathematically it really should be there. Okay, so it's really not, this part's not hard in calculating, it's just a matter of having that formula memorized. So we're going to go the integral from 0 to 2. Square root of, and then we're going to do dx dt squared, and then dy dt squared. And then we can either do that on the calculator, which this one looks like it would be a calculator one, or if we happen to know if the integral is not too difficult, we can do that. Okay, That should be the things that we need to know calculus-wise in parametric mode. So go ahead and finish up the assignment or get started.